This is section 8.4, area of triangles. Okay, so the first thing we're going to write down here is right triangle area formula, which is on page 468. So jot that down. So basically what it says is the area of a right triangle is half the product of the lengths of its legs. Okay, so what that means is if we've got a right triangle, so 90 degrees there, the legs are this side here and this side here. The ones coming off of the 90, those are both called the legs. The one opposite the 90 is called the hypotenuse. So in this case, we don't care about the hypotenuse at all. We just care about the legs. And usually with the legs, they call them base and height. That's probably what we'll use for most of these. So for the formula that I would write down, I would go area is equal to 1/2 your base times your height. Okay, so 1/2 BH. Then you just plug in, your base and your height and find your area. So like for this first one here, find the area of a right triangle with side lengths of 8, 15, and 17. Okay, so I've got a right triangle, and my lengths here are 8, 15, and 17. Well, I know 17 automatically has to be my hypotenuse, or my one opposite my 90, because the hypotenuse is always the longest side of your right triangle. So I know that side there's got to be 17 for the hypotenuse. And then it doesn't matter where the 8 and the 15 go. They could be, either there or there. It doesn't matter. Because when we do the formula here, we're going to end up multiplying both of them anyways. So our area would be half of our base times our height. Well, our base would be 15. Our height would be 8. So half of 15 times 8. So if I solve that out there, I would kind of change the order around here and do half of 8. Half of 8 would be 4, and then if I take 4 times 15, that comes out to be 60. You can do that on your calculator as well. Half times 15 times 8, so 60. And then when we're doing area, our label is going to be, in this case, inches squared, or square inches. Okay. All right. Now sometimes the triangles aren't always going to be a right triangle, but we're going to use the same formula, and I'll kind of explain how that works. So altitude of a triangle is the perpendicular segment from the vertex to the line containing the opposite side. Okay, so what I'm going to do here, I'm going to label this triangle ABC. And I'm going to make my vertex C. And if they ever do something like this, they would specify what the vertex is, so you know which one you're making your perpendicular segment from. So what I do then is it's a perpendicular segment from the vertex, so coming from C to the line containing the opposite side. Well, my opposite side would be that side AB. So basically what it is just a line straight down there at 90 degrees. I'm going to put a D here where that meets. That is called the altitude. Okay, so basically this line from C straight down like that, that is the altitude. The altitude is also the height of a triangle. So when we were using that formula there, instead of having base times height, you can do, or you're going to do base times height still, but your height is not one of the edges. It's from a vertex straight down. So that would be your height in our area formula, which we'll do some of those later. Okay, so that's when it's inside your triangle ABC. You might also have situations where it goes outside of your shape, so let me kind of show you here. So if I've got A, B, and C, and if, again, my vertex that I'm using is C, this would be a situation where our vertex, or not our vertex, our altitude would go outside of our shape. So technically, to go straight down from C to this opposite side AB, so if I go straight down to C here, to this opposite side AB, I'm actually outside the shape, because if I go to make my 90 right there, C drops straight down to that bottom side is actually not going to be inside this triangle here, it's going to be on the outside, but this corner point here we'll label D as again, and that C to D would be our altitude, or our height of that. Okay, so even though it's not inside the shape, we can still use that as our height of the triangle. Okay, so sometimes you'll have it where it's outside of that triangle. Now this one here is where it's on the triangle, so if I go A, B, C again, and if my vertex is C, if I go, so this would be like a 90-degree triangle here. If I go from C straight down here to my opposite side AB, what's going to end up happening is your side AC is the same as your vertex. Okay, so that's just like our right triangle formula, how our height was one of the legs. This side here, and we'll put a little D there as well, so A and D are the same point here, right on the corner. So with a right triangle, your height or your altitude is just one of the legs. Okay, so just kind of depending on which point you pick as your vertex. So sometimes it's inside the triangle, sometimes it's outside the triangle, and sometimes it's just one of the sides of the triangle. It just depends on what type of triangle you start with, and really what your vertex is as well. Okay, and then it says here the height of our triangle is the length of our altitude. So again, from C straight down to D, C straight down to D, C straight down to D, all of those are altitudes. So what we can do is we can use those as heights for our area formula, and I believe that that's what the next thing is here. Yeah, so basically our next thing is the triangle area formula, which is on page 469, and that's just showing you a different look at a triangle. So like a triangle like this is how their picture is, and then they just show here, this in a different color, they just show that, say this is our vertex right there, the height would be straight down at a 90 degrees, and then our base would be the side that we're dropping straight down to make the 90. So you can use that same formula, area is equal to 1/2 your height times your base, but this time your height isn't one of your legs of your triangle. What it is it's a straight line from your vertex to the opposite side, okay, and making that 90-degree angle there. So it's the same formula, just your height comes from a different spot, okay? Alright, so let's go to our example sheet then, and we're going to do this problem here. So we actually did one together already, find the area of a right triangle with side lengths 8, 15, and 17. That's that first one we did on the other sheet. So let's look at the second one here. So it says, using the figure at the right, find the area of each triangle. Okay, so let's start with PQS. So PQS is that one right there, PQS. Okay, and they want us to find area. So what I'm going to do, I'm just going to do it down here. So for A, I'm going area of PQS. So what I would want to do is I want to find my height and my base. So that triangle there, that triangle there looks something like that-ish. And our 90 would be kind of shooting down like that. And we've got to figure out our different pieces we need. So our base in this situation would be this side here. So looking at our picture, it looks like that would be from Q to S. So that looks like it is 1, 2, 3, 4, 5 units across there for our base. And then our height would be going from this R point, because when we're on a coordinate plane, all of those make 90s. So our vertex here is P, and we're going to go straight. Usually it's straight down when we're like this, but in this case it's kind of straight across, but that still would be our height. So it looks like that would be 1, 2, 3, 4, 5, 6 there. So if we plug that into our formula, our base is 5, so we would go 1/2 times our base, which is 5, times our height, which is 6. So 5 times 6 is 30, times 1/2 would be 15. So our area of that first one would be 15, and then since they don't have like inches or anything like that, you just call it square units or units squared. Next one there, for B, our triangle is PRS. So PRS looks just like that tiny one in there. So this one is going to be a right triangle because our PR, that line that shoots straight down there, is meeting at the 90 degrees. So that would be a 90 in there, making that a right triangle. So this one drawn out something like that. And we've got a 90 there. So our R to P is the same height as we had before, so that would be 6. and then our base would be from the R to the S, so it looks like just 2 units there. So then we use that same formula. Area is equal to 1/2 our base, which is 2, times our height, which is 6. 2 times 6 would be 12, times 1/2 would be 6. So our area of that pink one there would be 6 units squared, or 6 square units. Next one for C, we've got PST. So PST, ooh, this could be kind of a tricky one here. So with this one, when I draw it out, I'm kind of at like a little bit of an angle here. So I got my point P kind of going off at a little bit of an angle. This one's also kind of going off at an angle. And then I'm something like that. Okay, so this would be P, S, and T. To figure out my different things here, this one for our height, we're almost going to have to go outside of the shape. So if we kind of do like a little dash here outside of our shape, that's how we're going to be able to get our 90 degrees, because we're going to want to drop our P down to that R. And then we just do the same thing, our height and our base. So from P to R, that's the same as it was for the rest of these for our height. So that'll be 6. And then from S to T, it would be 1, 2, 3. And you don't, when you do this, you don't count the distance from the R to the S that's outside of that triangle, because then you would be figuring out the area PRT instead of PST. Okay, so just be careful on that. But anyway here, so now we've got area is equal to 1/2. Our base is going to be from S to T, which is 3, times our height, which is outside the shape on this one, so it would be 6. And then 3 times 6 is 18, times 1/2 would be 9. So the area of our green one there would be 9 square units, or units squared. And then the last one, what they want us to do is they want us to find the area of PQT. So PQT is all of them put together, or basically the whole thing there. So for that one, how's it going here? Oh, something like that. Yeah, P, Q, and T. Okay, so our height again would be that same P straight down to the R, which was 6. And then our base would be Q to T. So if I count from Q to T, it looks like 1, 2, 3, 4, 5, 6, 7, 8, I believe. So 8 for our base. So all the way across there is 8. So then to find our area, we would do 1/2 of our base, which from Q to T is 8, times our height, which would be 6 again. So 8 times 6 would be 48, times 1/2 would be 24. So our area there would be 24 units squared, or square units. Okay, and then we are back to this sheet here, and that looks like it's it for notes. Okay, so your book page assignment for this is page 471, 1 to 18 all. There is a little printout sheet with it that might be helpful, so you can kind of draw your vertexes and stuff in there, and maybe just do some sketches on that. So that might be helpful, but that's your assignment for tomorrow or the next day or whenever.